I guess we're back again. Third time's a charm. Hopefully this one doesn't take as long. This is a similar question to the last example. It's asking, is 2, 3, 4, 1 a term of the sequence? I have a lot more time now, so I could slow this down. But basically this is asking for, like somewhere along here, does 2, 3, 4, 1 land in that particular sequence? So this is a term of the sequence. This again is like u sub 1. And this was u sub 2, u sub 3. I don't know what this one is. So it would be, at this point, considered u of n, and I'm trying to see if n actually would work in this formula. So I go back to the very generic formula, which I didn't show you on the prior example, so you can kind of apply this to that if you wanted to. The nth term is the first term plus n minus 1 times the common difference. And so in this case, I'm trying to figure out if 2, 3, 4, 1 fits in the sequence. So the first term is 2. I do not know if this works or not, so I'm trying to find out what like this would be n is 1, n is 2, n is 3, etc. What n would work for this. I do know the common difference was 7 because this is the same one we were doing on the prior video. And these each go up by 7. So again, if I wanted to solve this thing, I would try to solve for n. So you can always distribute that 7 and just make a regular like linear type equation out of it and solve for n. I'm going to do that. I'm just going to save myself a couple steps and subtract that 2 first, which would give me 2, 3, 3, 9. And I'm just going to now rearrange this and put that 7 in front of the n minus 1, only because I want to remember that my next step on this would be to divide by 7. And really that's my key, is if I can get this to divide by 7, then I know it fits in that pattern of adding 7 every time. And so I have a job to do, and this, you could type this in your calculator. I do not have one handy, so I'm going to do this, and I'm just going to check it and see if 7 goes in here evenly. So 7 goes into 23 3 times. That would give me 21. Subtract, bring down a 3, goes in there 3 again. 3 times 7 is 21. Subtract 2, bring down the 9, and at this point I'm done. I can put an X here because 7 doesn't go into 29 evenly. Therefore, the answer to this is no. It is not part of the sequence because it does not fit the pattern of going up by 7 every time, even though that would be way down. It'd be in the 330th something term is where we're approximately close to, but it doesn't work. So as you can guess, you have a u try 4. That's your job right now. Same idea. Show it's arithmetic. Look back at the prior video if you need to slow down or look at some examples. Find the formula in general, 50th term, and then check if 2 different particular members would be sequenced. So pause the video. Also notice it's a little cold in my basement, so I had to warm up here. Pause the video. Do all 5 of these, and then check your answers. Pause. On pause, because you're done. Don't be recording. Don't be watching this unless you've done the u try 4. And now here are your answers. Right there at the bottom. Hope you can see them. Hope they worked. If not, this is a conversation we can have in class. So I have 2 more examples to go, and then you're going to try a couple, and we're going to move from there. So this is asking you to find k given that these 3 are consecutive terms. So I know that these 3 things are right in a row in a sequence, and I'm asked to find k. So I have a couple ways to do that. The first thing I know is that their common differences have to be the same. So k minus 3k plus 1. Very important that I put this 1 in parentheses. Notice it's the term that comes after minus the term in front. That has to equal the difference between these 2. So I can switch. So I can get rid of that. What I just did is I'm looking at the difference between these 2 in a row, and I'm also can find the difference between these 2 in a row. And if the common difference is the same, then they are an arithmetic sequence. And since I'm telling you it's arithmetic, I'm going to go ahead and find what that value of k is. So this would be negative 3 minus k, because this term comes after it, so then I subtract the term prior to it. Now I'm just going to do a quick distribute that minus sign to both of these. And that's going to be your kind of trick with these, is taking care of that. Now I'm going to get all my like terms on the same side of the equation. So I'm going to bring this k right here over to this side. And in doing so, I have a whole bunch of k's going on over here. And I have k plus k is 2k minus k. All of that equals negative k. And then I'm going to go ahead and also move the 1 over here. So when I do that, this side would equal negative 2. And if that's the case, if negative k equals negative 2, then k has to equal 2. And there's my answer, just by doing the common difference of two consecutive terms in a row. And I can also do this using that idea that we talked about before, and that is that this middle term, okay, hold on, this is going to be a little bit messy up here. Get rid of all that stuff, get rid of that, come up here back with my blue pen, because I keep forgetting I have that blue pen. This middle term right here has to be the average of the other two terms. So if I were to average 3k plus 1 plus negative 3, that means I have to divide them by 2. That should equal the middle term of k. So that should be the average of the two extreme terms in this consecutive case. So again, I'm going to multiply this 2 over. So I'll change this so you can kind of see me doing that. I don't like having a denominator, so I don't know where that 2 went. So I'm going to come over here and multiply 2 by both sides. Those cross out. Here I have 3k plus 1 plus negative 3, so that would become 3k minus 2 equals 2k. Again, the 1 and negative 3 gives me the negative 2. Changing color so we can kind of see what's going on, ignoring the autocorrect here. If I subtract 3k and get all my k's together, then I would have negative 2 on the left equals 2 minus 3k, which is negative k on the right. And again, that leads me to k equaling 2. So if there are 3 consecutive ones in a row, you have 2 options. Find the common difference of the first 2, the common difference of the second 2, and those differences should be equal. Or if there are 3 in a row, you can average the 2 extreme ones and it should equal the middle one. So as promised, you have an opportunity to try this again. These are consecutive terms, so that means that they are in a row. So you can look back at the prior example if you need, but you should pause the recording now and give this thing a shot and then see if you got the right answer. The answer may surprise you, so pause. And you've unpaused it, which means you already did the problem. Here is your answer. K equals 0. Shocking, I know. It can happen. If I put a 0 in for k, my terms would be negative 1, 3, and 7. And notice that I'm going up by 4 each time. So my common difference is 4, and that would be an arithmetic sequence, even though this thing doesn't know what it's doing. All right, last example. Finding the general term for an arithmetic sequence. There's probably a couple ways to do this. I'm going to show you it using a system of equations to begin with, and then we can kind of play around with this as we go. But what I'm telling you right now is that the third term is 8, which means for this particular value, n is equal to 3. And so I can write an equation for that. Again, I'm just going to jot down the generic equation here. It's first term. This time I'm going to put that d in the front, only because I know I'm going to have to use this a little bit in a minute. So what I know is that the third term is 8. So this 8 really is the third term. So that 8 can go right there because that's u sub 3. I have no idea what the first term is. I have no idea what the common difference is. But in this first term, n is 3. So this can be written as 3 minus 1, which is 2. maybe I should have put that d in the back. I changed my mind. I am going to put that d in the back. As soon as I fix that, I'm going to put the d in the back just because it makes more sense for this particular example to have that d in the back. Now, I'm going to change colors because I also told you the 8th term is negative 17. So again, in this particular one, n is equal to 8, and this is the 8th term. So I can put negative 17 right here as the term value. Still have no idea what the first term is, but I do know n minus 1. N is 8, so if I put 8 minus 1 in here, it would equal 7, and I don't know the common difference. But what I have now is a system of equations, and I'm trying to solve for both the first term and the common difference. So the way this is set up right now is, since these have different numbers in front of them, and these are both just u1s, if I actually take this entire second expression and subtract it from the top one, I'd have 8 minus a negative 17, which becomes a plus. So that would be 25. u1 minus u1 canceled. And 2 minus 7 equals negative 5d. And I just very quickly now, by dividing both sides by negative 5, know my common difference is negative 5. So that's the first piece that I need to know. And I can take that negative 5 and I can put it here or here. It doesn't matter which place I put it. Since I have the opportunity in this magic thing, because this d is here, to make that go away, I can put a negative 5 right there where that d was, and I can solve this for u, the first term, u1. So I'll have 8 equals u1, negative 5 times 2 is negative 10, so that becomes minus 10. And if I want to solve this thing for u1, I would just add 10 to both sides. And I come over here and add 10, and I now know my first term is 18. And those are the only two things I need to write the general term for u of n, because now I've got this and I have this. So I apologize for all this crazy business happening behind my back. I can now write u of n equals first term, which we decided was 18, even though it has some interesting notation there, plus, or actually, hold on, I have a negative 5, so I am going to change that to minus 5 times n minus 1. So my terms are going down in value, which makes sense because I started at 8. 5 later, I'm at negative 17, so they're going down. The other way you could write this is first term plus n minus 1 times negative 5. I kind of like the way this one looks a little bit better. But that's example 6. There are other ways to find that common difference that we can play around with a little bit. If I take the 8th term, sorry, I'm almost out of time, but if I take this, negative 17, goodness gracious. If I run out of time, I'm going to switch over and just show you the next example because I have answers for it for you. If I take negative 17 minus this one, which is 8, so I'm kind of finding the difference between your y's, and I also come over here and go, there's my x's, 8 and 3, and if I were to go 8 minus 3, I would get negative 25 over 5, which would also give me my common difference, which you'll notice is sort of in the position of slope in this equation. And that is enough extra math for you for right now. Here is your try 6, pause it, and when you're done doing it, look at the answer. So pause. On pause, because I'm almost out of 15 minutes of all I get in this recording business. Here are your answer. Should have gotten 6n minus 1. That one looks to me like the computer generated a simplified version of our equation. Hope that helped. Hope you enjoyed it, and we will definitely be chatting about this. That is all.